All right, let's take a trip. We're heading to the very heart of our solar system to get to know the one thing that makes all of this, all of us, possible: our star, the sun. So let's kick things off with a number that might just change how you see everything: 99.86%. That's it. That's the sun's share of all the mass in our entire solar system. Just think about that for a second. Every planet, moon, asteroid, all of it, it's just a tiny, tiny fraction of what was left over. Which, when you think about it, is kind of wild. It means our solar system isn't so much a system as it is, well, the sun, and a little bit of cosmic dust that it hangs onto. So, here's our game plan. We'll start with the basics, then we're gonna slice the sun right open to see what's inside. After that, we'll dive straight into its fusion engine, fast forward through its entire life, and then zoom all the way out to follow its incredible journey across the galaxy. Okay, let's dive right in. First up, the sun's basic stats. So what is our sun exactly? Well, technically, it's a G2V yellow dwarf. It's about 4.6 billion years old, so it's kind of middle-aged. And the scale is just hard to wrap your head around. It weighs as much as 333,000 Earths. You could line up 109 Earths side by side just to match its diameter. Oh, and here's a fun one. Because its gravity is so immense, it's the most perfectly round object we've ever found in nature. Okay, now for the really cool part. Let's go inside. We're going to journey from its fiery outer atmosphere all the way down into its core. So here's our descent plan, our roadmap to the center. We're starting way out in the mysterious corona. Then we'll punch through the visible surface, the photosphere. From there, it's a deep dive through the interior until we finally reach the very heart of it all, the core. First stop, the corona. This is the sun's wispy outer atmosphere, and it holds a massive puzzle. For some reason, it blazes at millions of degrees. That's hundreds of times hotter than the surface just below it. How is that even possible? Scientists are still figuring it out, but it has something to do with the sun's mind-bendingly complex magnetic fields. Right below that mystery layer is the photosphere. Now, this is the surface of the sun that we actually see from Earth. All the light and heat we feel, it radiates from here at a comparatively cool 5,772 Kelvin. Once light leaves this layer, it takes just 8 minutes to reach us here on Earth. But that 8-minute trip is just the final leg of a much, much longer journey. You see, a single photon of light created in the core can take over 100,000 years to escape. It just bounces around the dense interior, getting absorbed and shot out again and again, on an incredibly long and random walk to the surface. And after that 100,000-year slog, we finally made it. Welcome to the engine room, the absolute powerhouse of the solar system, the solar core. This is where all the magic happens. The conditions down here are just insane. We're talking nearly 16 million degrees, and the pressure is so intense that it's 150 times denser than water. This is the only place in our neighborhood hot and dense enough for nuclear fusion to happen. And get this, the core is still spinning 4 times faster than the sun's surface. So what does this engine do? Every single second, it fuses 600 billion kilograms of hydrogen into helium. That is an unbelievable amount of matter being transformed constantly. And here is where the most famous equation in history comes to life. Of that 600 billion kilograms, about 4 billion don't become helium. Instead, they are converted directly into pure energy. That's E equals mc squared, in action, right there. That is the energy that powers our entire world. But here's the part that's going to absolutely blow your mind. If you took just 1 cubic meter of the sun's core, the amount of energy it puts out is about the same as a compost pile. I'm serious. The sun isn't powerful because each little piece is super efficient. It's powerful because it is just unbelievably colossally huge. Okay, so now we know how the sun works day to day. Let's shift gears. Let's stop traveling through space and start traveling through time to see the entire life story of our star. So our sun's story started about 4.6 billion years ago, and right now it's a stable, mean sequence star, but it's only about halfway through its life. In another 5 billion years or so, it'll start running out of hydrogen fuel. That's when it's going to swell up into a massive red giant, swallowing the inner planets. After that, it'll gently puff its outer layers away, leaving behind this tiny, super dense corpse, a white dwarf, that will just slowly cool off for trillions of years. And I mean, look at this transformation. It's just staggering. The sun's radius will balloon out by more than 250 times. It'll be so big, it's going to consume Mercury, Venus, and almost certainly us here on Earth. And it'll shine over 1,000 times brighter. It's going to be a completely different star. All right, for our final leg of this journey, let's zoom out, way out. We've seen the sun as our star. We've seen it as the center of our system. But it's also a traveler on an epic journey through the Milky Way galaxy. You know, the sun isn't just sitting still in space. Not even close. Right now, our entire solar system is whipping around the center of the galaxy at 251 kilometers per second. That is over 500,000 miles an hour. And that's just one of the ways we're zipping through the cosmos. So, even moving at that insane speed, how long does it take for one lap around the Milky Way? About 225 to 250 million years. That's so long, we have a name for it, one galactic year. Now, this really puts the sun's age in perspective. Since it was born, our sun, with us in tow, has only made this trip around the galaxy about 20 times. You know, when the dinosaurs were walking the Earth, our solar system was on the complete opposite side of the Milky Way. And that's where we're going to leave it, with that image of our star not just as a ball of fire, but as a 4.6 billion-year-old traveler, an ancient witness that's completed 20 epic laps around our galaxy. It just makes you wonder, right? What secrets of the cosmos has it seen out there on its long, silent journey? Thanks for coming along.